Welcome to the Lionheart Academy. We are continuing our trigonometry lessons. We're in lesson number 49. We're almost towards the end of our lessons. Right now we have been, for the past 3 lessons, we've been solving oblique triangles. And we covered case 1 where you're given one side and 2 angles. Now we're covering case 2 where you're given 2 sides and then one opposite angle. Okay, one opposite angle to the 2 sides, to either of the 2 sides. And then from yesterday's lesson, we talk about the basis of our solutions and how we go about approaching the problem. We did a few examples. But today I would feel like we probably need to do a few more examples. Okay, so let's go ahead do a few more examples today and how we approach. Alright, so this is SSA, so given 2 sides and one opposite angle. So let's say we're given in a triangle ABC. Given in triangle ABC, side A, okay, lowercase a is side A. Side A equal to, let's go ahead and do 12 inches. And side B equal to 15 inches. Alright, and then measurement of angle A. Okay, measurement angle A, let's go ahead and do 35 degrees. Okay, alright, so if you remember the table from yesterday, let's go ahead and take a look at the table from yesterday, and we can use the table to help us identify the solutions. So this is a summary of case 2, side angle. Okay, side angle. So if the given angle is less than 90 degrees, which is an acute angle, we're going to use this column. We're going to compare our the side that's opposite to the angle compared to the other side that's given. So we're going to compare A to B. If A is greater than B, there's one solution. If A is equal to B, we also have one solution. If A is less than B, then we have to compare to A to the possible height of the triangle. Okay, B sine A. And then if A is less than that, a possible height, then there's no solution. You cannot make a triangle. If A is equal to that height, then we have one solution. And if A is greater than that height, then we have 2 solutions. Alright, so let's take a look at this. So we know the angle A given to us is less than 90 degrees, and we know side A is less than B. Okay, so if we look at the table, that brought us to this third row here. A is less than B. So based on A is less than B, we have to compare A to the height of the possible triangle. So let's compare A to B sine A. Okay, so let's calculate. A is 12, B sine A is 15 times sine of 35 degrees. So 15 times sine of 35 degrees, that is equal to 8.6. So 12 is greater than 8.60 inches, and then that means we have enough information to tell us that it should be a 2 solution. So we are looking for a 2 solution triangle here. Alright, so that means the conclusion is 2 solutions. Okay, so let's draw a diagram first before we go ahead do the solutions. Okay, let's draw a possible solution here. So side B is 15 is longer than side A. Okay, so I'm going to draw it like this. Alright, I'm going to set angle A here, side B here, 15 inches, and side A here is 12 inches. Okay, and this is 35 degrees. So this is definitely possible, a possible solution, angle A, angle B, angle C. But the other possible solution, okay, I'm going to use a dashed line here, is that for A not to be on this side but be on this side. Okay, so that's another possible solution. So now yesterday I drew them in the same triangle, but today let me go ahead and draw on the other triangle. So we will avoid some confusions. Maybe you'll be able to see a little better. So the side B is still 15 inches, but side A, 12 inches will come back here. Okay, it will form definitely a obtuse triangle for sure. Angle B will be obtuse, so we're going to call it B prime, and this we're going to call C prime. But notice B is still 15 inches, and this is still side A is still 12 inches, and this angle is still 35 degrees, but it just closes in like this. So those are the 2 possible solutions that we will be coming across dealing with this. The reason is the length of A is less than B, but it's greater than that height, which is right in the middle right here. Let me go ahead and show you where the height would be. The height, or B sine A, the H, is right here. So if A is greater than that, so it has possibilities to swing around. So the height, that's the same height here. Okay. This is the H. Okay, this is the H, which is equal to B sine A. It's just equal to B sine A. Alright, so now I think we are ready to go ahead and solve. Okay, I'm going to call this solution 1. I'm going to call that this picture on the right solution 2. So let's start with solution 1. Let me take it step by step. I think yesterday maybe I was a little rushed. We made some mistakes, but we corrected. Alright, so this is a very simple sine angle situation. We're going to use law of sine. Alright, so the first thing is we want to solve for angle B. Because angle B is opposite sine B and angle is opposite sine A, so we can set up a proportion using the law of sine. So sine of angle B over B is equal to sine of angle A over side A. Okay. So to solve for sine B, we multiply both sides by little b over A times sine A. Now this is this will give us the value of sine B, but in order to find the measurement angle B, we need to use the inverse sine, or the arc sine of B. Arc sine B divided by A over sine A. Okay. So now let's go ahead and plug in the numbers. So sine B is 15 inches, sine A is 12 inches, sine of angle A is 35 degrees. So we're gonna get use our calculator to find out what's the measurement of B, and then do the arc sine. Okay, so we use our calculator to do the arc sine here. 15 divided by 12 times sine of 35, and do the arc sine. So it's about 54.80 degrees. 55.8 degrees. Now, so let's go ahead and write this down. 45.8 degrees. I said it wrong. That's 45.8 degrees. Alright, so this will allow me to go ahead and calculate angle C. And this will allow me to go ahead and calculate angle C. So measurement angle C will be 180 subtract measurement angle A, which is 35, and subtract measurement angle B, which is 45.8 degrees. Alright, so we take 180 minus 35, and then subtract 45.8. So that will give us about 99.2 degrees after rounding. So angle C is 99.2 degrees. Alright. Then that means we only have to solve for side C. Side C is the opposite side here. Is little side is AB here. Side AB, side, which is also called little c, side C. Okay. So little c, we're going to use law of sine. Over sine C is equal to little a over sine A. Sine capital A here. So sine C is equal to A times sine C, capital C, divided by sine A, angle A. And A is 12 inches times sine of angle C, which is 99.2 degrees, divided by sine A, which is sine of 35 degrees. So let's go ahead and get the value here. So sine of 99.2 degrees divided by sine of 35 degrees. Multiplied by 12. So that will give us 20.65. So we can round off to 20.7, 20.65 inches. Okay, 20.65 inches. So we have done solution 1. We have finished solution 1. This is the first set of the solution. Now we're gonna come back and check the answers. Okay, before we're done. But this is solution 1. But what does solution 1 has to do with solution 2? Now remember, we find angle B from using the arc sine, right? 45.8 degree. But you have to remember, arc sine only gives us the angle in quadrant 1. However, if I go ahead and have 45.8 degrees, right? Sine of another angle is also positive, which has the same. So there's another angle in quadrant 2 whose reference angle is 45.8 degrees, which has the same value here, 45.8, 45.8. But it also has the same sine value as 45.8. And how do I find that angle? Well, I go ahead and use 180 minus 45.8, so which is 134.2 degrees. Now those two angles, they have the exact same sine value. That's why, but one of them is first quadrant, one of them is in second quadrant. So when we do solution 2, we know that B prime is has the same sine value as B, but it is an obtuse angle, which just means it's in quadrant 2. So we know we can solve for angle B prime by using our knowledge of trigonometry here, simply by doing 180 minus measurement angle B. So we don't have to go ahead go through the same process. Well, we could, but if we go ahead and use the same arcsine, you will get 45.8, so you won't get the B prime, because the primary answer that returned by the calculator doing arcsine is in quadrant 1, not in quadrant 2. So we have to do that extra calculation ourselves to get the 134.2. So this is 134.2 degrees. Okay, so that means this angle B prime is 134.2 degrees. Okay, then we can go ahead and find C prime based on what we have always been doing. So measurement angle C prime is 180 minus 35 angle A, and then minus angle B prime 134.2 degree. Okay, so let's go ahead and subtract that. So angle C prime is going to be a very small angle here. Let's write down angle C prime will turn out to be 10.8 degree. Alright, so let me write that down. So it's 10.8 degree. Oh, I forgot to write this is 20.65 inches. Alright. This. Okay. So now we have one last thing we need to look for. It's called little c prime. Okay, c prime is a b prime, which is the distance c prime. So we use law of sine again. So little c prime over sine of angle c prime is equal to a over sine a. So c prime is equal to a times sine of c prime over sine a. Alright, so let's substitute 12 here for a, and let's substitute 10.8 degree for c prime, and let's substitute 35 degree for a. So let's type in the calculator. Alright, we got about 3.92 inches. 3.92 inches. Okay, so let me go back and write it up. So this is 3.92 inches. Okay, so now we are completely solving two solutions. Both of these are possible solutions based on the information given. So if A is 12 inches, B is 15 inches, and angle A is 35 degrees, we can come up with two solutions like this. Now, yesterday we did talk about, or the day before, we talked about a Mollweide's law formula that will help us to check our solutions. So let's go ahead and check our solutions here. So check using Mollweide's formulas. Okay, so let's check to make sure that we're doing the right thing or our calculations are correct. So this is b minus a divided by 2 divided by cosine of c divided by 2. Alright, so this formula, we're going to use b minus a to three sides. Okay, so let's go ahead and 15 minus 12 inches divided by c is 20.65 inches. Now, because we're using the round off number here, so your answers may not be exactly the same unless you can use as accurate as number possible. Alright, sine of angle B is in this case is 45.8. So it's 45.8 degrees minus 35 degrees divided by 2 divided by cosine of angle C. Now what was angle C here? Angle C was 99.2. 99.2 degree divided by 2. Okay, so let me go ahead and find out what that is. 15 minus 12 divided by 20.65. So it's about 0.1452, 0.1453. Okay. So alright, let's do this. 45.8 degrees minus 35 degrees divided by 2 sine 99.2 degrees divided by 2 cosine divide is about 0.1452. Now actually the round off, there's a round off error here, so but they're very close. They're close enough to the thousandths, so yes, we'll check. Say yes, we have done a good job here. We got all numbers correct. Alright, so solution 1 is great. Now let's go ahead and check our solution 2. Let's use the same formula. Now let's check that formula. So we can use b minus a over c equal to sine b minus a over 2 divide by cosine of angle c minus 2. So we're going to use c prime here and c prime here. Okay, so b is still 15, a is still 12, but c prime in this case is a smaller number. It's 3.92. okay, 3.92. let's plug that in. And angle B in this case is much larger. Angle B was B prime. Actually, it was 134.2. So I should say B prime here. Okay. So 136.2. I'm sorry, 134.2 minus 35 degrees divided by 2. Okay. And divide by cosine of c prime. Now c prime is extremely small this time. It was only 10.8 degrees, so we do 10.8 degree divided by 2. Okay, so let's go ahead and plug in the calculator and see what happens. Again, there should be some kind of round off error. So I got about 0.7653. If I have exact answer for this, or as many as decimals as possible, then this will be round off error will be very small. Okay, but it's possible because we already round off, especially 3.92 is round off, and even the 134.2 and 10.8 they are round off. Okay. This is sine. Okay, divided by cosine 10.8. Alright, so this one is 0.7649. So this is approximately the same. Okay, I know they're not exactly the same, and the round off error is a little bit greater than that one, but I think we're getting the right answer here. We won't be able to get exact unless we use the exact numbers here. That we'll get the exact answer down here. But when they are close enough in such a case, then we realize, okay, we're not doing a bad job here. Our solutions should be valid. Okay. Alright, so this is another way to approach our case 2, and then I haven't done any other examples here, but I think this is a very good example for our case 2. You can go back to check this. This is probably the most complicated part of case 2. Anything else for case 2 is very simple, but again, the key is we want to go ahead use our table here. Use our case 2 table. I'm showing you here one more time, case 2 table, and follow this case 2 table. And if you have no solutions, that will be very simple to deal with. Just need to check the conditions to find out whether you have one solution or no solutions. And one solution or no solution, then that is actually very straightforward. The 2 solution examples, well, we have done 2 examples so far, and hopefully this example is clear to you. And if you have any other questions, please let me know. Leave your comments on the comment sections, and we will continue on to case 3 and case 4 using law of cosines in our next lessons. Alright, so well, hopefully we'll see you and join us in our next lessons. Goodbye.